You're not holding open.
I'm actually running their US.
Actually kicked off the blockchain way back in my day, so really glad to see such a thriving membership now, even despite whatever happened in the market this week. So glad to see you all here. Like Bennett said, I work at AngleList. I do a lot of crypto stuff. I just got us up and accepting USDC, a stablecoin, and I'm also deploying DAOs as investment entities. AngleList is a platform that lets you invest in startups. They facilitate the creation of venture capital firms or syndicates. So yeah, we're trying to get startups funded using blockchain rails. Prior to that, I was working on a startup, Bountyum, where we were deploying DAOs for on-chain businesses, accepting customer orders and issuing supply orders as bounties. So I've been playing with smart contracts for a while. I think they're a really powerful tool. And the goal today is to get you guys comfortable with smart contracts as a tool, understanding what they are, understanding how they exist, where they live, and how to deploy your own. We won't go any crazy code. It's going to be some really simple functions we're writing, but just try to show you guys the tools and get you comfortable so you can then go out, and experiment, learn on your own. I'm going to give out my contact information at the end. I love sharing code. I love looking at your code. So anytime you have a question, day or night, you send it over. I'll reply probably in like 5 minutes. So I hope you do reach out. But yeah, that said, I should also kind of explain what smart contracts are and why they matter. So I guess I didn't prepare a presentation, so stop me if this doesn't make sense. The way I think about smart contracts, so you have a blockchain, right? And you have a bunch of nodes that maintain a ledger. And when people broadcast, transactions on, say, Bitcoin, right? Somebody says, hey, I would like to send, X units of Bitcoin from Y public address to like Z recipient, right? And those usually look like big hex numbers, 0x, AB, 1, 2, whatever. And so these are 3 pieces of data that the sender then gives to a node, and the node then communicates out to other nodes until everybody adds it to this long list of transactions, right? Transaction 1, 2, all the way back to like the first transaction on the chain. And so the nodes are doing a really simple job of the only thing they want to check is, does this guy actually have X units to send? And if so, we're going to send it on, right? Do you guys follow how a transaction is a piece of data that gets appended on to this piece of data that just grows and grows, which itself is the blockchain? Does that make sense? Cool. So then Ethereum came along, and Ethereum invented this concept of what if we let you put slightly more complex data into your transaction and let the nodes interpret them as instructions. So this is what's called an opcode. It says, instead of just telling you, I'd like to send X units to 0xZ, I would actually like to give you these instructions, which will then tell you what to do with my Bitcoin, Ethereum, whatever. So I might tell you, hey, if, this other variable way back in the past in transaction 3 reads value 7, then you should send the money to recipient Z. Otherwise, don't do anything. So these are instructions that nodes can interpret and then take action upon. Those are called opcodes. Does that make sense? Cool. Okay. Now you might think, well, it will be a huge pain to try to communicate complex instructions with opcodes, because opcodes, if we bring it back to programming languages, will be very similar to like syscalls. So we need a layer of abstraction to make those opcodes easy for the sender to communicate. And that is where we get smart contract programming languages, the first of which was Solidity on Ethereum. On Bitcoin, people are trying to invent some, they don't actually have native opcodes, so it's really hacky, but you can actually look at, programming language on top of Bitcoin. And then there's competing smart contract platforms too, something like, Lisk, Algorand. They actually have totally different opcodes. So at that point, you're talking about, languages written for different operating systems entirely. So that's kind of the lay of the land, what we can work with. And our goal today is going to be to write our own smart contract in Solidity, then compile it to opcodes and put it onto a real blockchain. We're going to use a test version of Ethereum called Ropsten, but it follows the same protocols as Ethereum. It's just, a ledger that doesn't actually have any value tied into it. No one cares about the units. You can get them free. So yeah, that's the plan today. I will pull up Remix now. I also have some other example code we can get into if we have time. But our goal is to do a really simple contract that just stores a variable. So you can go to remix.ethereum.org. And this is actually an internet native IDE. So the Ethereum Foundation built this and you can write Solidity in it, and it comes with a bunch of tools on that sidebar there that will let you compile your Solidity, deploy it into a virtual machine of the Ethereum network, or deploy it onto an injected node communicator. So, a wallet essentially. MetaMask is the one I'll be using today. But if you have MetaMask installed, if you don't have it, it's easy to install. It'll take a second. You can then interact with the sidebar and deploy onto, a test network. You can even deploy into mainnet if you want to, waste some money. I don't encourage that. But yeah, I'll let everybody get a chance to install MetaMask, pull up Remix. Any questions, welcome now too, while people are kind of installing tools. Cool. There's no questions. I mean, why did you guys come today? Why were you interested in deploying a smart contract? Nice. We will leave notes something back. Finish. Good answer. Oh.
Earn smart contracts.
What do you want? What do you want your smart contracts to do?
I don't know. We do like risk management for AMMs.
For payments?
Yeah, for
Nice.
AMMs.
AMMs?
Yeah, AMMs.
Automated market?
Yeah, automated market makers.
Oh, MM. Okay.
Yeah.
Okay. Cool. Cool. Yeah, we can even look through the Uniswap source if we have time. It's actually a pretty straightforward contract.
Yeah.
Aside from like the calculus and that. Everything else is simple, and then there's like hard math. Like, whoa. Street structures is the limit of my math.
What's MetaMask for again?
MetaMask is a wallet. Yeah, it's a full-on wallet as a browser extension. Most wallets are actually like desktop software, so it's pretty impressive that they implemented this in like just JavaScript. But it talks to Infura, if you've heard of it, which is like a node as a service. A node is somebody that communicates with other nodes running a blockchain protocol. So it's like a peer-to-peer network, right? And running a node would require your own software. Like it's called Geth. Hopefully if I minimize this, I don't have anything. Yeah. Okay. So I think I have Geth installed on this machine. I don't. But Geth is a node client. So the Ethereum Foundation said if you want to talk to other Ethereum nodes, here's the protocol that you put your messages into. And then Geth just lets you, in a user-friendly way, say, hey, here's my transaction data, and it backs it with the Ethereum protocol, and then has like a list that keeps up to date of other nodes you can talk to then broadcast your transaction to all the other Ethereum nodes and get onto the real time. Now, Infura wraps something like Geth into like a normal API. So you can go to like Infura.com or this, and it's just like talking to any other API. And then MetaMask is a tool that talks to Infura so that it uses JavaScript and send transactions out to the blockchain. So MetaMask is like a centralization point. Most people use dApps, use MetaMask, and it's all talking to Infura. And so if Infura went down, like most Ethereum dApps would be unusable for most users, which is pretty concerning. So I'm very eager to see a truly decentralized user-friendly service. Yes. Yes. Sorry. That would make sense. Yeah. Cool. All right. So I'm assuming everyone has MetaMask and has Remix open. So we are going to start. I guess I already started, so let me even get rid of this. So first thing about smart contracts is that they're only useful if they're open source. The whole point of a smart contract is to provide some kind of trustless logic, right? Your goal is to put instructions onto this decentralized network, and your instructions can never be, stopped from operating. That's the novelty. That's why you're using this instead of like a centralized cloud server. So users can only actually interact with your contract in a trustless way if they can read the instructions. Otherwise, I could put, malicious instructions in there. So the first line you'll see here is standard to pretty much every smart contract that just basically claims this is under an open source license. Anyone can look at my code, use my code, modify my code. I won't sue you. It's not strictly necessary. Your smart contract will work without it. but that's why it's there. That's the SPDX license. So we are going to use Solidity. And the way you declare what your programming language is for a smart contract is with this keyword pragma. And then you say which language you're using and the version number. Now we're just going to use any version between 7 and 9. 9 is the most recent one. Yes. So yeah, and what this does, the reason this is important in Remix is that Remix will automatically reload a compiler depending on which language number you're choosing. We don't care about any features that are exclusive to anything between 7 and 9. So yeah, just throw in pragma, Solidity, and then greater than or equal to 070, less than 090. So we're going to start our contract. This will look a lot like any object-oriented language. We're going to use a keyword contract to declare that we're making a contract, and we're going to name it. And the name of this is going to be storage. And all it's going to do is store a variable. So when users interact with our contract here, we want them to be able to do two things. And this isn't even going to get into any transaction-based logic yet. All we want to do, where's the eraser? I don't know where it is. All we want to do is let users tell the nodes, hey, that smart contract, which is at this unique location, it's going to look like an address, like you might see on a user. I want to set its variable to be this value. Or we could let the user ask a node, hey, that contract at this thing, what is its value, So we're just writing two functions, set the variable, read the variable. So the first thing we do, like an object, oriented language would be, declare a variable at the class level. So in Solidity, your number type is uint, an unsigned integer. And you can declare, how many bytes you want to allocate to storage. And this is relevant for this concept called gas. I'll show you kind of the options we had before. Uint 256 means using 256 bytes to store the number. So we're going to start with that. Now, everything on a blockchain, when you write data onto the chain, is expensive. You have to pay somebody on the network to say, hey, I'd like to put data on the blockchain. The reason for this is to prevent denial of service attacks. You don't want people sending garbage data to these nodes that these nodes are then obligated to broadcast. The whole point of a blockchain, right, is that anything you want to put on the chain has to get onto the chain. There is no censorship possible. So to prevent, somebody just spamming that and overpowering the nodes, you make it cost something in the chain's native currency, in this case, Ether. So that's the simple version of every transaction, every piece of data has a standard cost. Now, when you have these things called opcodes, you're also asking nodes to perform computations. So you could have a different, what if somebody, wrote this really, really crazy function that took 10 million computational units and could take down every node. So we also have to charge not only for every piece of data that you write, but for every computational step you're asking nodes to take. And so the first is just, a standard transaction fee. The second is called gas. So how many bytes we want to allocate to this value matters. If we do uint 8, that is a very small value. And people who want to change the value won't have to spend very much gas because it takes few computational steps, right? You only need to rewrite 8 bytes. So let's do 256. We're living large. And then we're going to write a function to set this value. Now, honestly, my study's a bit rusty, so I might be going back and forth to remind myself of specific syntax. But it's going to look like this, and we'll walk through step by step. So we are going to do a function, and we're going to name it. And it's going to accept a parameter, and all parameters are typed in Solidity. So it's going to be the same type as our value. And we're going to name it new value. And we're going to declare its visibility, which is going to be public. We're going to let anyone call this. And there are some more modifiers we could add on to this. We'll go through some of them. There's also custom modifiers, which we'll go through. But for now, it's super, super simple. All we're going to do is do value is equal to new value. So anyone's going to be able to call this. And then we want to be able to read the value. And there's going to be no parameters for this. And it's also going to be public. And all we're going to do is return value. And there's an error already. we need to declare the return type. And we can declare just view, which means, so we talked about this concept of gas, right? You can actually optimize your gas a little bit by communicating when you're writing your contract, what kinds of operations it does. And then nodes can, get ahead of any potential usages of gas and optimize them out. So the different kinds of mutability include, there's pure for when you're not even reading any values, which is not the case. We're reading a value. There's view for when you're just reading. There's blank for when you are reading and writing. And then there's payable when you're actually asking the user to send some ether in addition to, whatever operations the function performs. So this is just view. And that's it. This is your contract. So what we'll do now is we'll actually compile it. You're going to see a lot of inputs here. We don't care about most of them. We declared anything between 7 and 9. So this compiling is fine. Language is Solidity, like we know, and we're going to use the default compiler. And so then if we compile, we see that it modified some metadata, and then we can go into this third part of the sidebar, the little Ethereum logo, and we'll see some options here. And so one thing yes.
Why did you write pure or payable to set value function?
Say that one more time.
Why did you write pure or payable function in set value?
Yes. So this is, I was just going through the different possibilities for that value, but we want this to be view because it's reading a value from the chain.
No, for set value. I'm asking.
Oh, yes. So if it's writing to the chain, but not asking the user to send any value, technically it's non-payable, but this is implicit, or there's a different keyword for it. So most people just leave it off, but it's between view and payable, basically. So does that make sense? Yeah, cool. Okay. So we'll see here, right? We can deploy and run transactions in here, and we have some options for environments. There's a VM, and you'll see that there's actually two kinds, London and Berlin. You guys might have heard that Ethereum is moving to proof of stake. And these two versions represent a proof of stake and a non-proof of stake implementation of Ethereum as a virtual machine. We're going to go with London, which is the most recent version. And you'll see an account here, which is your account within the virtual machine. It gets allocated a bunch of ether for test purposes. Gas limit we don't care about yet, but then we can deploy to a virtual machine and see right here under deployed contracts, we have this little thing, and it has our two functions. And this is the compiled contract deployed into your virtual environment, and we can interact with it. We can set the value and see the returned output. I'm sorry, we can't see any output. There's no output, but we can see the transaction happening here in the console. And then we can read our value. Now, if we called read value without having set the value first, we see 0. This is another thing to note about Ethereum, is that Ethereum actually comes with defaults for everything you do. And that matters a lot. A lot of smart contract bugs happen because values can be used and manipulated before they're actually set. So something to keep in mind is you're making more complex contracts. For example, if you wanted to restrict something to only the contract deployer, a lot of people will forget to set that, and it causes some high profile bugs. But yeah, are there any questions so far, or does deploying, interacting make sense? Yes.
Can you have multiple contracts in the same file?
Yes, you can. In fact, you can have multiple of the same type. Oh, you said the same file. I thought you meant the same deployed in the same environment. Yes, you also can do that, and they will show up in the compiler. So like, contract, other storage, and then you'll see both of them show up as options under here. So if you get a contract, you'll see both of them compiled. So it would be best practice to separate them into files, I would say, because you can import across files. So yes.
These accounts,
Well, like, where do they come from?
yeah, like who account is that?
Yes. So this is on Ethereum is like a protocol, right? And there's one main like network of nodes communicating with each other called the main net, which is where like your valuable ether lives.
Okay.
This is a virtual machine, which I would describe this as like you basically in your browser are running a bunch of like node simulators that are talking to each other under the Ethereum protocol. So these are fake user accounts,
that you can, so a user account on Ethereum, your address, like 0x whatever, is actually just what's called a public and a private key. And so the 0x number that you see as your address is the public key that other people can identify you as. And then your private key is something that you have like, on your machine and can sign messages with, and no one could forge them. So that's why Ethereum works. You can be sure that, 0x3, that guy didn't actually send the transaction unless, you check their private key signature against the public key. So basically, they generated a bunch of these pairs, which is like totally free. It's just math, right? You're just generating basically two really large primes. It's not actually quite that in Ethereum. That's basically what it is. And so they just generate a bunch of these. And then when you're running your own Ethereum network, you can like allocate Ethereum out of thin air to users. And so that's basically what they did. They made 100 private key pairs, gave them all Ether so that you can switch between accounts and pretend to be different users and test your contracts. Okay, cool. Yeah. And you guys will notice, the user actually used to deploy the contract as well as call the set value function, they now have a little bit less Ether. They had to spend gas to both deploy the contract as well as set the value. So cool. That's using the VM. Now, you also might have seen we have an injected Web3 and a Web3 provider option. So let's click on to injected Web3. And I am on main network right now. I obviously don't want to be. We're going to switch. If you have MetaMask installed, you're going to go to the Ropsten test network. And you will see here that I have some Ether. This Ether is worthless. But what this is a bunch of nodes, real live nodes out in the world, running the real Ethereum protocol, but on a ledger that no one regards as legitimate. And so it's kind of a bit mind-bending to wrap your head around, but like, any ledger of like Ether, it's only actually valuable if like the rest of the world considers it valuable. Like there could be a world someday we decide that Ropsten Ether are worth money and this would be worth money. But for all intents and purposes, this is the same as regular Ethereum, but the Ether is just worth $0. So it's really good for deploying contracts and testing them. And it'll actually, you'll have a transaction delay because there are real nodes talking to each other, communicating about your smart contract. So if you don't have any Ropsten Ether, you can drop your address into the chat and I can send you some. There's also these things called Ropsten faucets, which I can also link to. And so these people will just give you some Ropsten Ether for free, but it kind of takes a little bit of time to actually go through. Chat. How much should I send each person is the question.
Is Ropsten mine still on that network?
Yep. Yeah, there are miners running on that network.
They don't just like make it.
Yeah. Yep.
But it's worthless.
For now, there could be a day where social consensus drives some value to it. I would be surprised. 0.3. I do wonder why the miners on Ropsten do what they do. Like, is it just charity or what? Because it takes real computational power. Alrighty. Okay. If you guys didn't hear that, the faucet only took like a minute. So if I'm too slow, feel free to do that instead. Alrighty, James Mahaffey is the last one I'm gonna send to. Oh no, okay, one more. All right, no more, cutting you off. So now that you all have some test network ETH to play with, if you click injected Web3 in your environment, Web3 is this kind of catch-all term to represent like interacting with decentralized networks. And specifically, this is referring to a JavaScript library, web3.js. And what that is a standardized library that wraps Ethereum protocol in JavaScript functions. And so Remix is using that library to talk to MetaMask and let you sign transactions, talk to contracts in Remix. So if we click our storage contract and hit deploy, you should see, what the hell? All right, you should see MetaMask prompt you with a transaction. And it's telling me it's going to cost this much Ether. I don't know why it's an unknown processing time. Probably because we're on a live network and maybe it's not able to get an accurate, set of network statistics. But if we hit confirm, we will see that as pending. And then once it goes through, you can see in the console right here, creation of storage pending, and then we see it in our deployed contracts, just like with the VM. But you guys notice the delay, right? That means we're talking to real nodes in a peer-to-peer fashion now. And it's the exact same thing that would happen if you were to deploy in the mainnet. Exact same experience, obviously a longer delay on mainnet because you're competing for scarce resources, but same concept. And it'll look the same in MetaMask and everything. Speaking of, triple check that you're on the Ropsten test network, not on the mainnet. I've accidentally used that before, and don't do that. Now we can do the same stuff, right? We can set the value, and I told you guys, right? Set value writes to the blockchain, so we have to spend some Ether to do that. So we can hit confirm, and that's what if you've ever used a dApp, it's a similar experience. If you ever have to hit like buy on Uniswap, it'll look like that, and that will be pending. And I think it already went through. So then if we read value, we see our value 1, but you'll notice, right? When we use the VM, set value, read value, didn't matter. They were both just functions. Now, when we hit read value, there's no prompting on MetaMask, right? It just calls it, and that's because it's only just reading the most recent version of the blockchain. If somebody else were to change that value, if I was like, if somebody wanted to load up my copy of storage on the Ropsten network, which you actually can if you want, you could set the value. And actually, I'll show you guys how to do that. So if you take this address here, you can load a contract that's already deployed to the blockchain, and you can load it in Remix in this little address button, and you can interact with my copy of storage, and I'll actually get an update. I'll have a new read value. So if somebody wants to do that, change it from value 1, we can see it come up on the screen here once Ropsten processes the transaction. And so I often do that if a smart contracts front interface is down. Like, I don't know if you guys saw the controversy with 1inch, which is a decentralized exchange, but they're basically banning US users in practice. But you could totally find the 1inch deployed address and just pop it in a Remix. Take their source code, which is open source. All right, they're doing layer 2 stuff, so it's actually not that simple. But if you find an Ethereum contract you want to interact with and you don't have an actual front end to use, you could totally just pop it into this address thing and then see all the functions interact with without a front end. So that's useful if you guys are ever, getting censored from stuff. But yeah, anyways, if anyone changed my set value, yep, we see a new one here. I didn't do that. Somebody else did that. So we're on a live decentralized network right now. But yeah, does all this make sense so far? Does the concept of how to use these tools, where the contracts are, is that making sense?
I'm not in science there.
Cool. Is there any, I would love your perspective. Is there something that didn't click?
Well, I don't know any coding at all, so I'm just talking.
Yeah. Yeah.
I understand the general premise of how blockchain networks work. Smart contracts. I from more than the application system. Not that how it is. But it's pretty interesting just to kind of get a little bit of insight.
Okay, okay, cool. Well, I mean, yes,
What if you set a value which is over 56?
that is a great question. Honestly, like, I'm not totally sure what will happen. Let's just find out. Oh, 256 bytes, which means that we can hold a max value of 256 times 8. So I hope I actually went over it. Yeah, okay. So somehow that worked. Okay, 2 to the 256. What is that in decimal? We must find the limit. All right, there's no way I can type that. So I honestly, I don't know. Maybe it overflows and it becomes a very small number.
Is it in bits or is it bytes?
It's 2 to the power of 256, which so bits, 256 bits then.
Oh, yeah, yeah.
Yes. Oh yeah, that's just.
Would people try with U and eight instead of U?
Yeah, let's do that. And we have to make this a uint8 now. Yes, good call. I think that actually would not break since you can go from uint8 to 256, but yeah, it won't work for our purposes here. Okay, so. So it catches the error, which makes sense, I guess. I don't know if there's any way to force this. We could like look at transaction metadata. What does it like actually look like when you're calling a contract, like in the Ethereum protocol, and try to like assert the value there. I'm guessing that nodes probably reject it out of hand when you try to send it. But yeah.
So when you reply this contract, this contract defines itself as some space. So does that cost any?
Yep. Yep. If you saw when I hit deploy here, I got a MetaMask prompt and it's costing this much Ether. So yeah, if
But is that based on the variables or the side of the file itself?
it's just on the, it does like optimize down. Like comments, for example, won't affect how much that costs. Yeah, but it will be, I think variable names do cost something. And I have seen people use inline opcodes to try to reduce down the size the contract will take. In my opinion, that's overkill. You know, as the contract author, saving, you know, a couple dollars isn't worth your time. But for example, when you're thinking about like parameters, I mean, the types is what's going to matter the most, right? If you can take a uint 256 down to uint 8, you'll save your users a lot of money in the long run. So, yes.
So this contract was to like allow users to set it to.
Yeah, it is a really simple one. But yeah, I mean, so we're going to move on to a more complicated one now. Most Ethereum contracts obviously actually deal with transactions and what to do with money based on variable values. But yeah, this is just getting the concept of like storing variables on chain down. Yeah.
Do you have any like real world examples of apps that are highly optimized?
It's a good question.
Or are they all kind of highly optimized all the time?
Yeah. I mean, there's definitely ones that are not that optimized. I mean, honestly, like Uniswap used to not be that optimized, and then they started to optimize, and then they decided actually deploying onto a layer 2 is a way better trade-off because they wanted to keep their contracts readable. And this goes back to the concept of like why open sourcing your contracts is so important. Because if people can't, first of all, you want people to double check you for exploits. And then secondly, you want to have a plausible claim of decentralization. You want to, when the SEC comes knocking on Uniswap's door, it's useful for them to be able to say, our users can read the contract. We're not pulling the wool over anyone's eyes. And so, when you're trying to like do crazy things to optimize tasks, you can't really make that claim very easily. You won't have any like PRs, pull requests in your open source repository that you could point to and say, look, other people are contributing. It's not just us, So yeah, they ended up just taking, there's this concept of a layer 2. We have the Ethereum protocol, and someone deploys a smart contract that can accept Ethereum transactions and basically run like an Ethereum VM, but somehow do it more efficiently, spend less gas than the nodes do when they're trying to communicate your contract calls. And so it takes some crazy math to do that, basically. Right now, the most common way to do this is this thing called an optimistic rollup, where somebody is looking at transactions getting sent into that contract and saying, hey, I'm just going to process these, even though I'm one central entity. And you can trust me because I'm going to claim, ahead of time, here's what the output of all these transactions comes to. And then other people are going to bet on whether I'm right. And there's this decentralized check and balance on my ability to just process as a central entity. So basically, it's centralizing all the transactions, but having a decentralized check on the centralized processor. And so it's kind of meta to think about. Somebody basically deployed an Ethereum VM onto Ethereum itself, but it's getting way cheaper. And so it's a great decision for Uniswap. Uniswap was like, we can make our code way less readable, but save our users some money, or keep it readable, but try to use this layer 2 thing, which kind of introduces some centralized presence. And it made sense for their use case. It makes it, somebody could shut down the centralized processors on, I think they're using Optimol is the name of the layer 2 they're using. But, that's the trade-off they were fine with. And no one has done that to the, Optimal processors yet, so.
One other question in the chat.
In theory, is it possible to deploy a contract without paying gas? Shreyas, I'm assuming you mean deploying like the contract in a way that the user can call its functions without paying gas. So a couple, you could push it to a network that is centralized or a test network, and you won't have to spend any real ether, and other users could interact with it. You guys saw somebody called my storage contract on the Robson network, and that was accessible to a user across the world. I don't know where they are, on a real decentralized network, and no one had to spend any real ether. So that's an option. But then you're kind of trading off some minor convenience for the user against decentralization. So at that point, I'd ask, why aren't you just using AWS? You could look at like a competing smart contract platform. Sometimes they're so cheap that it's basically free. Or you could use one of these layers 2s like we're talking about. I wouldn't say any of those are close to free yet, like maybe Matic, that's sometimes under a cent. So yeah, those are kind of your options. But am I understanding the question correctly?
Hey, hi. I don't know if you can hear me.
I can hear you very quietly.
I can just put it in chat. No worries. So like technically what my question was is like, if you're, let's say in terms of NFT, right? I'm selling a certain amount of NFTs, right? Instead of paying gas for each NFT that I deploy, or like the smart contract that I deploy for each NFT, is it possible to push that gas to the buyer, for example, and just add it on to the actual cost of the NFT? I don't know if that question makes any sense.
Yeah. What did you say?
He's talking about like making NFT. I think you can make it so that like buyers pay for it, so that you don't have to like make, if you're making like a 10,000 points, you don't have to make. You can have contract set up so that like the buyers will pay the gas fee.
Yeah.
But you still have to pay the contract fee.
Yeah. Yes. So to answer your question, deploying the contract, you will always have to pay for. If I'm interpreting your question correctly, you're trying to avoid having to pay the mint for like all of your buyers before they buy. And yeah, David, right?
Yeah.
Like David was saying, you could design your contract in a way that, moves the mint transaction to the buyer, where basically the standard NFT contract is 0x. Yeah, here. Up. I'm going to go back to like the last project I interacted with. What? Okay. there's a standard contract that everyone uses, ERC721. It's mainly maintained by 0x cert, and their implementation forces the person that deployed the contract to also be the one that mints all the contracts. But you can write an ERC721 contract. Basically, the way you would approach this is that like the contract under the hood looks like this. You know, it would be public, it would be non-payable, and it probably wouldn't return anything, right? And basically, there's this array, there's this, well, really a mapping from numbers to strings. And they're token URIs, a universal indicator of the token's value. And usually those point to image hosts. And basically, when you mint today, you would send a, you know, token ID, and you would send a URI, and this will be a UNT256. And today, these contracts, this isn't correct Solidity, but I'm just trying to get the point across, ask that, you know, in their constructor, which is the function that automatically gets called when you deploy the contract. I think we just write it like that. And they declare this variable called an owner to be whoever happened to call this function, the constructor, also known as the person that deployed the contract. And then they just require that whoever calls this mint is the same as the owner. And you don't have to do it that way. You can instead make it so that mint can be called by anybody. But the trade-off is that you don't get to just extend the existing implementation that everyone else uses. Hosted, you know, it'll be something like github.com/0xcert/ you know, ERC721.sol, something like that. You don't get to do that, and you have to just write all your own logic from scratch. That's basically the trade-off, but totally doable. And there might already be an implementation out there that you get to use. So to answer your question, this comes down to how you choose to write the function. Does that make sense? Cool. Cool. So we kind of got a sneak peek of like more advanced Solidity. I think it's time to move on to that, write a contract that deals with value. So what if we wanted to make it so that people have to pay to set our variable? We had to say, you know, the deployer of the contract is going to declare anybody that wants to set my variable has to send 1 ether. Well, let's do like 0.01 ether to actually set the value. So we are going to do that now. So to store values, we are going to have a variable called price. We're going to make it a UNT256, and we're going to denominate it in this unit called WEI, W-E-I. That is the smallest unit of ether. It is named after Eugene Wei, who in the late 90s basically wrote all the theory about how smart contracts should work before any blockchains existed. So very impressive guy. Up there with like Nick Szabo is kind of the other main theorician there, who also has a unit named after him. So price and WEI, and we are gonna, like I said, have a constructor, and we are going to make this accept the variable. And it's usually best practice to repeat variable names. Sometimes Remix will yell at you, but I think this is the way you should do it. Yeah, see, shadowing an existing declaration. I think it's the best way. So yeah, it's that simple. And then when we compile, you guys may have noticed if you have auto compile on, if we were to try to deploy our contract, we now see an input there, right? And so this is where we would input, you know, whatever we want the price to be. But so getting back to our contract, we now have to make it so that the guy who calls set value will have to send enough value to set the value. When I'm talking about two different values, I'm talking about value in ether versus, you know, the variable's value. So we have this thing called a message in a smart contract. Solidity lets you see, you know, whoever's calling my contract function, right? It's just like sending a contract on the Ethereum blockchain. Sending 1 ether from one address to another is the same as calling a contracts function. They're the same thing. It's just that, you know, if you're not calling a function, there's just less data in the transaction. You're leaving some fields blank, whereas somebody that is calling a contract function has to add, oh, by the way, here's the function I want to call, here's my arguments. That's all, but they're the same thing. And so message is how we can access some fields about the transaction. And message.value will tell us how much ether the contract caller is sending when they send us the arguments. So to recap, there's a contract, right? And contracts, when they get deployed, they get their own address, just like a user, right? You can see it right here when we looked at my contract that was live in Robston, right? And so I'm a user, my address is 0x2, and there's a contract that lives at 0x3, and I'm gonna call its function, and so I'm gonna tell the whole Ethereum network, hey, I wanna call its first function, right? Because functions, when they get compiled down and put on the blockchain, have to be numbers. And you know it has X, Y, Z arguments, so here are my arguments I'm gonna pass to it. And I'm going to send some ether along with this transaction, not only paying the gas fee, but also some extra ether that the contract can just keep. This is a concept to wrap your head around. Contracts can hold ether. And so that's the other thing I'm going to send. I want to send 100 way. And all that gets wrapped into one transaction object, right? And that gets sent to nodes, and nodes broadcast it, and they look at the logic of the contract that's stored on the blockchain, and they run the function. And then the blockchain's state gets updated. So message.value right here, we want to access that variable, and we want to make sure that it's greater than price and way. And so this require keyword is interesting because it will, you guys saw earlier, right, that our transaction got rejected before it even spent any gas. Requires let you do the exact same thing. They let you send back a transaction and make sure the user doesn't waste gas doing whatever happens next in the function. These lines, obviously not expensive here, but I might have like 20 lines in this function that the user no longer has to spend money on. So this is angry at me, and it's angry at me because this now needs to be a payable function. Whoever asked that question earlier. So it is now payable, which means that users can send value to the function. And we see that it's been compiled. If you have auto compile on, if not, hit compile. And now we can deploy. So I'm going to make the price of my contract 100 way. We're going to deploy. And now MetaMask is like, hey, do you want to do that? And I say yes. And it got processed. And now if I try to set the value, let's send it. And I didn't add any value onto the transaction, so this should not work. The set value, the read value should tell me once this processes that it's still the default value of 0. Wait a second for that. Zero, see? Now, if I want to send something, I can use this input here. Let's send 101, because I believe it did a greater than, not a greater than or equal to. And let's set the value, and it's saying it's going to error. That's pretty peculiar. Let's try sending the transaction anyways. What's that? Did we get an error code? Well, that's pretty weird to me because we did set the value. So maybe Remix is just, upset with me about this. Another thing you can do. Someone just sent me some ether. Thanks. You can feel free to, I have the same address on mainnet, just saying. So this is a tool called Etherscan. If you go to MetaMask, you go to your transaction history, you can click on any transaction you did, including a contract interaction, and click this and view it on Etherscan. Etherscan is a centralized service that scans the Ethereum blockchain and records the transactions and presents it as human readable data. So let's look at this. It says that my transaction was canceled and the value transfer we did not complete. Oh, I know why this is. Okay, we didn't do anything with the value. And this is a new feature of Solidity. So transactions now, if you don't do anything with the value that gets into the contract, they revert automatically unless you implement something to do, like when you receive Ether, what to do with it. So let me Google that quickly, if you don't mind. Bum, bum, bum. Yes, okay. You need this anonymous function for what happens when you actually send value. So this is a function with no name. Expected a state variable declaration. Let me look at a contract I wrote this summer and see what I did there. If anyone can find my stupidity, please tell me or message the chat. I'm not seeing an obvious difference. All right. That one worked without any complaint. I think Remix is just being salty for no reason. So I'm just going to ignore it. The next thing we could do, we're kind of running out of time. We could deploy a DAO if you guys wanted to. Walk through what the address primitive is in Solidity, kind of the other wrinkle of Solidity as a language. Or we can just talk through questions of this or wrap it up. What are you guys thinking? We have 3 minutes. Yeah, let's do Q&A then.
Are there any like good public libraries?
Yeah. So my favorite is Solidity by example. And they just talk you through a bunch of different contracts you could implement. The first one is probably very similar to the storage one we did. And then they walk you through different data types. I kind of assumed you guys were okay with that. Reading, writing a state variable, we did that today. Ether and Way, we just got to that. And then you can get into loops, mapping, all very similar to other programming languages you've seen. Yes, thank you. And then this is where it would get interesting. This is kind of what we didn't get to today, but it would be this thing, you know, of your contract can send Ether elsewhere. You know, it could receive some Ether, forward it on, you know, when some state variable changes, send it, that kind of thing. So I would start here if you attended this session today and understood how it went. And then, yeah, this is my favorite resource. Apart from that, there's tons of forums on this kind of thing. There's this one called ETHDev, which is my favorite. There's also the Ethereum Stack Exchange. So people are very friendly there. I might even reply to you. So I would go there first. But yeah, I think the best way, I wouldn't read Medium articles. If you learn that way, maybe, but I would just, you know, write contracts and deploy them and play with them if I were you. So.
And is Remix like the best IDE or are there?
Yeah. Yeah, so I'm a fan of Remix. I haven't seen a better IDE. Consensus sometimes publishes tools, but I think they've slowly decided to just direct people to Remix. There are these smart contract testing suites called Truffle, and so sometimes it can be nicer to develop locally, and then you can take advantage of one of those. There's other ones out there, but it's kind of industry standard. But yeah, I would stick with Remix. That's where I develop. Yes. Yes, it will cache in your browser. Sometimes my browser just deletes them without telling me. So I would, you know, make a folder on your desktop and just copy and paste between them. Yes.
What it takes to get into AngleList?
To get into what?
Get a job in AngleList.
Oh, yeah, we're hiring a co-op.
Oh.
So that's the first thing you should do is co-op, and then you get to work with me and watch me make Solidity mistakes. Next thing after that, all our jobs are posted on AngleList. AngleList is actually two companies. We are a job board, and we also make VC firms. I work on the side makes the VC firms, so we post our jobs in the job board, so you can probably find it there. We're hiring a lot of places. Financial infrastructure, probably most applicable to this crowd, where you work on both crypto and fiat rails to move money for startups and VC firms. So yeah, in terms of what it takes, you have to love startups. You have to think that startups are where all the innovation happens, because we believe, and you have to care about the user story. You have to understand what a user wants to do in AngleList and why, and then orient your day around that. It's definitely not a pure coding job. You don't get to sit in the corner and code. You have to, work with your collaborators and learn on the fly. So if that sounds like you, you're a good fit. Yes.
AngleList only to go back to like VC work, real estate.
We've run real estate deals. I don't think it's something we want to do. I worked prior to my current project. I was helping build out a secondaries marketplace where startup shares could be sold in a liquid fashion. That is a really tricky business proposition because startups like being illiquid. But that eventually looked kind of like NASDAQ. So I mean, maybe if we grow really fast, we can try to take on the counter trade in public markets. That would probably be the next area of expansion. But there's much meat on the bone adventure, I think. So there's too many people paying lawyers hundreds of thousands to start a VC firm. So we got to conquer that first. Yes. Yes. So I asked, we're open to it. It's not something we have formally done before. So if you send me the Slack message, you should write an email to George Ryder. Well, I'll give you his email. He runs all our hiring, and just pitch him on it. Pitch him on why you think it's a difference to the company. CC me, and I'll absolutely pump you up internally. Which frankly, it's something we've never done before. So you kind of have to make your own luck there. But I think it would be really cool. We can really big business operations. We get to work, Twitter celebrities. So if you're into that, I mean, really pretty cool. We have some really cool investors in the platform, really smart people, and you'll be helping source for them, helping run some of the fund infrastructure, keep them compliant, that kind of thing. Really funds.
Were you most excited for this one?
Yes. There's kind of two categories of innovation I'm excited about. One of them is smart contracts to automate money movement. And I think that specifically, I think every investor will become a smart contract. And I think that every company becomes a smart contract. So I'm really excited about those two things because I think it'll basically mean that anybody who's not directly creating value to customers will be removed from the value chain. And customers will get paid really cheaply. And people are really good at making things will get money. So I'm excited about those developments. I think it'll create a pretty nice world. The other category is anonymity enabling smart contracts. I think there will be incentive networks created to help obfuscate everything you do and make you unobservable. And I think that will kind of introduce a new